Okay, so in this video we'll talk about the second type of second type of tissue, connective tissue. And so we want to first and foremost think, how is this different? What other functions do we need to do besides absorption, secretion, protection? So connective tissue, what makes you connective? Well, first of all, you'll have lots of extracellular matrix. In other words, you have lots of stuff around the cells. You can afford it now because you're not first contact, all right? And we call this ground substance, and we see protein fibers in that. We call it a number of other things, but ground substance is something like chondroitin sulfates and glucosamines. Protein fibers like collagen and elastin and reticular fibers. They'll have fewer cells, so they're always less organized. You won't see nearly as many nuclei in connective tissue. Okay? And so we want to look for that. It has a number of functions to fulfill here. So it does connect, hence the name, right? You're always going to find this as the outermost part of something because it encloses and separates, and that's why this was part of membranes as well. It supports, so here as we talk about like bone and cartilage, it stores, and this would be like adipose, it stores energy, right? Blood is a connective tissue, protects from infection, the white blood cells, right? Packing material like the loose areolar, again, stores energy. Bone stores minerals too. And so we're going to look for a variety of functions, and we want to look for their structures to, represent this. So it's classified by connective tissue proper, or supportive connective tissue, or fluid connective tissue. All right. So connective tissue proper. In that, you would generally see the cells and the nuclei is what you're going to see. The cells are called fibroblasts, and it's because they build fibers. You see adipocyte, fat cells, mast cells, that's part of your protection, and macrophages, which are also part of your protection. And then there's also these mesenchymal cells that you'll see, and they are able to produce more stuff like the fibroblasts will. So the mesenchymal are multipotent, so many lots of potential adult stem cells. So this mesenchymal can make other, it produces lots of things. It produces more cells. The fibroblasts, they tend to be fixed in place. They're not moving around. And they will make the extracellular matrix. They produce then the collagen, elastin, and reticular fibers. The macrophages tend to wander, and they are large eaters, and they pick up bacteria, viruses, dead cells. So they're called scavengers, and they help defend you. And then mast cells are also fixed and stay in place. In other words, they are part of your defense, and they release heparin and histamine, which helps with anti-clotting and basically vasodilation. And this promotes inflammation, so they help to mount a response when you've been infected or contaminated by something. All right? So here's a nice scanning EM of these fibers, and they would be found in the extracellular matrix, right? And the cells themselves would be surrounded by this. So they are mostly protein in nature, all right? Collagen, reticular filaments, and elastic fibers. All right, so what value do they have? So here's a lot of collagen with a nice scanning electron micrograph. Here's some elastic, right? Then colored in yellow here. All right, so collagen is flexible but not stretchy. Collagen is a rope, right? So when you pick up a rope, you realize, yeah, I can bend it and move it around in places, but I really can't stretch it. I really don't want rope to stretch, right? And reticular are just fine, short pieces of collagen that are often branched. So these help form networks for support and organization of cells in a lot of our organs and glands. Then elastic fibers, again, still part of that extracellular matrix, is stretchy. So whenever we find that, we know that there's going to be some ability to stretch and expand and then relax the tissue. So again, all these fibers are embedded in ground substance, which is a polysaccharide, right? So a large sugar with protein known as proteoglycans, right? So protein sugar. So we find, again, this kind of complicated extracellular matrix that we didn't need or want in epithelial tissue. So starting with the different types, and again, this is that connective tissue proper. loose connective tissue, areolar. You will be looking at this in lab. So the extracellular matrix is mostly collagen. That's what you see, these large, long, thick branches here. Generally stains a nice pink with little elastic fibers, so some tiny, thin, elastic fibers tend to be much thinner. And then these are the nuclei of fibroblast cells for the most part. Okay, so the fibroblasts made all these filaments. So loose areolar, and it's not well organized. Look, it's a lot. Look, that's a lot messier than those epithelial cells. But it's kind of the packing material. It surrounds, and it's fairly thin. There's this structure called fascia that surrounds your muscles and separates them. If you eat red meat, you'll still see this, because usually the cut of meat you get will be several different muscles, and they will be separated from each other by this, really loose, very light. It's white generally, but not thick like fat, So kind of fills the spaces. So between glands, muscles, nerves, and helps separate things. So loose connective tissue is the adipose. So extracellular matrix, there isn't much in this one, so this is an exception. The cells are called adipocytes, also an exception, not fibroblasts, and they are filled with lipid. So here you've got a lot of blood vessels in here, so don't destroy. These big cells here and here, are going to be, and some then blood vessels made from simple squamous kind of scattered throughout here. This connective tissue stores energy, because lipids, we can break them down and use them for energy. They cushion, so they help to prevent, impact, problems with impact and rubbing. And they insulate, so they help to keep the heat in the body. Reticular is also a loose connective tissue proper. And here you see, we see a whole lot more name for these reticular fibers, which are short and branching collagen fibers, Generally in several different directions. We are back to having fibroblasts as the main cells, and they make this collagen. Again, just not really well organized. We find this in the framework of various organs and glands like liver, spleen, lymph nodes. All right, dense, regular, and irregular connective tissue. All right, so you can get a feel for why we call them dense, regular, and this is irregular. So we're referring to the direction of the fibers, and the fibers here, of course, are collagen for the most part. I said that stains a nice pink. So you really get this feel for how few fibroblasts are in this field. Most of this is collagen, and all the fibers are running in the same direction. Whereas down here, the dense irregular, there's a lot, dense, there's a lot of fibers, collagen fibers here, but they're not all running in the same direction. Some are coming out at you, some are going sideways. So now, I want you to understand something. Collagen, we said, is flexible but not stretchy. So collagen, the direction of the fibers is basically the way fat tissue will move. So this we see in tendons and ligaments. And that's why, you can tear a tendon or a ligament, because if you try to put stress or strain against, the direction of the fibers, you'll damage the tissue. So here, dense irregular, which is very common to our skin, which can undergo a lot of impact in various directions and pull and twist and stress and strain. This irregular gives us, again, strength in the direction of the fibers. Okay, so we've got, again, dense collagen fibers. The cells are fibroblasts. The strength of the tissue is in the direction of the fibers. So these irregular fibers are can take a lot of different movement in a lot of different directions. The blood supply to this tissue is actually poor, and so if it is damaged, again, you don't see any blood vessels in here. If it's damaged, it tends to take a long time to repair. So a dense connective now, elastic, and again, we've covered the loose ones, and we're looking at dense tissues, and we still call these connective tissue proper, simply because, again, these guys are made of fibroblasts, and they're made of similar fibers, some collagen, elastin, and reticular fibers. So the elastic dense connective is going to have more elastic fibers. So what you're looking at here, again, and the fibroblasts make them, there's, again, not many fibroblasts in here, but we have this kind of squiggly, looking stuff, and interspersed with thinner elastin. So, again, collagen and elastin. They're found between bones in the spinal column, in the arteries, in the heart itself, and in your respiratory airways. So basically this elastin, and more of this elastin, right, will allow them to expand and then relax. So places that I need stretch now. So we really, in the last couple of types of connective tissue, we haven't talked much about stretch. When I have an elastic tissue, I'm going to put it someplace where I need some stretch. And the heart and the blood stretch as blood, the heart and the blood vessels stretch as blood enters them. All right, now the supportive connective tissue. All right, so that's, those are the examples of what we call connective tissue proper, and separated by loose and dense. So supportive connective tissue, cartilage is an example of that. Now, in this case, the extracellular matrix has collagen, but we have a lot more of these chemicals called proteoglycans. And again, this is stuff like glucosamines and chondroitin sulfates, things that they try to sell people when they have joint problems. Okay? So there's a lot of water molecules that get trapped in here, and this gives us a nice cushioning and protective property. So the cells now are not fibroblasts, but chondrocytes. And they're found in these little tiny spaces. They get surrounded by their own matrix. They are definitely going to give you support and protection. We put them on the caps of bones so that bones can't rub and erode, right? They are avascular, like the dense, regular and dense irregular connective tissues. So when they're damaged, it takes a while to heal cartilage. 3 major types are hyaline fibrocartilage and elastic, and these are named again for the majority of what we find in the matrix. All of them will have chondrocytes. So here's some pictures to separate, what do these things look like, and we'll be looking at hyaline cartilage and elastic cartilage in lab, not the fibrocartilage. So you don't need to know that one for the practical. Right, so the most abundant is hyaline. Again, it resists compression, it's a cushioning. Covers the ends of the bones, all bones in the body, right? It attaches the costals or ribs to your sternum. It's in your nose, and it's those rings of your trachea that you can feel, right, in your neck region or cervical region. All right? So the fibro has more collagen, hence the fibro, than hyaline, with bundles seen, and again, we're not going to look at examples of this. This is also very good at withstanding compression, but it can withstand more because of this collagen, okay? And it resists pulling and tearing, right? So we find this where we need some extra cushioning. So this is in between the vertebral discs, right? Found in the vertebral discs, in between the vertebra. There are menisci in the knee and the pelvis. We find this between the 2 hip bones and the jaw joints that we'll look at later on. Elastic cartilage has mostly elastin, with some collagen in there. It stains a little differently, so that's what you're going to look for in the lab. It stains kind of a bluish, whereas this one, the hyaline cartilage, it picks up a really lovely purple. And looks, hyaline actually means glass-like, and it does look really smooth and glassy when you look at it. Whereas the elastin's a little messy. It's got all these little fibers, stress looking like cracks in it. All right. This is where I'm going to need some extra stretch, right? So ears, epiglottis, this, right, that guards your trachea when you swallow. Auditory canal, that's going to have to stretch as sound waves enter. All right? The bone, which we have a whole, right, system devoted to this. So it's the other supportive connective tissue. I said, your word roots os or ost are used when we're describing something relative to the bone. Now the extracellular matrix is actually rock. Yay, that's why it lasts so long. It's inorganic salts, right? Mineralized calcium phosphate. There is collagen in it, so bone does take some stress and strain, and if there's no collagen, they become brittle. I believe that's what we call osteogenesis imperfecta. The cells in here are now called osteoblast, osteoclast, and osteocytes. They are in lacunae, little tiny spaces, but it's really hard to see them. This is a really high magnification. All right. There are lots of words to know, and I'm running out of time on this video, so I'm going to pick back up on this in the next one.